Hi everyone, this is Tila here from My Teacher. In the last 10 months, I don't think that I've uploaded any other videos because I really couldn't find much time to do content like this. But after I looked at the YouTube video that I posted the last time, I realized that there's been a huge demand from a lot of people. So I decided to just go on with it and probably try my best to be a bit more frequent in updating the videos. So let's get to the chase. Today's topic is on trigonometry. So these are some compilation of past year exam questions. And we have about 4 questions that we're going to look into in today's session. And you will be getting all the available answers, and the documentation will be provided for you to print out and work on it at your own pace. Okay, so let's start with question number 1. Given that 15 cos squared theta plus 2 sin squared theta equals to 7, show that tangent squared theta equals to 8 over 5. So this is the type of identity question where you have to try and use certain type of identities to make sure that you change from the left hand side to make it equal to this particular term. Alright, so the first thing that I see is that there is cos and sine on this term, and on this term you only have tangent. So let's make use of that. So we'll start by first dividing all the terms by cos. So which will make it look like this. 15 plus 2 sine squared theta over cos squared theta equals to 7 over cos squared theta. Now, the reason why I'm doing this is because I want to be able to eliminate one of the cos or sine function. So in this case, what gets written is the cos function, right? So you also notice something else happening right after this. So notice that if I were to simplify this, I will end up getting a tangent square theta. So we are almost there to get a tangent square. But we have one other issue to solve. So 7 over cos squared theta is actually equivalent to 7 secant squared theta. So this is because of the reciprocal. Now, we also know that secant squared theta can be expressed in terms of its identity. Therefore, let's make that substitution. Okay, tangent squared theta equals to 7, 1 plus tangent squared theta. So this is basically the identity that you would normally know or identify as like this. 1 plus tangent squared theta must be equivalent to secant squared theta. Okay, so this is an identity. Right, so let's continue with this. So now the other step is for us is to just expand this and simplify and make all of the tangents or all of the terms on the left hand side to form a quadratic equation. Alright, so I mean not even quadratic equation, but all the tangents on the left hand side and the values on the right hand side. So just let's show it. Okay, so I'll end up getting something like this. 7 tangent squared theta minus 2 tangent squared theta equivalent to 8. Right, so you'll get this after you expand and rearrange. Right, so let me just simplify this further. 7 minus 2 is 5. Tangent squared theta equals to 8. And notice that we finally end up with tangent squared theta 8 over 5. So I guess we have finally shown that this is equivalent to this. Okay, question 2, or part 2 of the first question. Solve 15 cos squared theta plus 2 sin squared theta equals to 7 for a particular domain. If you look at this, this is actually the same equation that we just simplified into one term. What I mean by that is we have one function of trigonometry instead of 2. So we have simplified this to this. So instead of trying to solve this again, let's make it a lot simple. So let's just use this. solve, because we know that this is equals to this, therefore we can use this to solve because it's a lot simpler. Okay, so first step. Okay, so tangent square theta, so I need to change it to become at least tangent theta, so square root it on the other side, so you'll get a plus and minus. So we're going to work with the plus and minus, so I'm going to subdivide this into two parts, and on the left side I'm going to use a positive value, alright, and on the right side I'm going to use a negative value. Hope you're following up until here. Okay, so the next step is always try to find something that we call a basic angle. Right. So notice that your question is in radians, so you must make sure that your calculator is in radian form. So make sure your calculator is in radians. Right. So if your calculator is in degrees, you will not be able to get the right answer. Right. So what we do in order for us to get the angle is that we do an arc tangent. So arc tangent is also written in a simpler way like this. Okay, so when you're using a calculator, make sure you are putting a bracket inside because it might not give the right or accurate value. Okay, so you will end up getting 0.902. So if you're getting a value like 56 point something, that means you have not changed degrees to radians format in your calculator. Now this is also known as the basic angle. So I'm just going to put a B dot angle sign. So this is called a basic angle. Now before we give the final answer, it's always good to sketch the quadrant in which the particular trigonometry actually lies. So we should know that by now. Here, the first quadrant, every single trigonometry will give you a positive value, right? Here, sine is positive. Here, tangent is positive. And finally, on the fourth quadrant, cos is positive. So you might remember this with different names. So for example, my teacher back in, I don't know, very long time ago, I was told that this stands actually for all science teachers are crazy. So yeah, until now I still remember it. So yeah, you might want to use that as well. All right, so anyway, let me just cut that short. Okay, so I would draw this diagram one more time and try to identify the quadrant of this. So this is a positive tangent, therefore this should be in this quadrant, and it's quite easy. So your basic angle will just match this angle. So that's one answer. So keep that answer here. Alright. Now, that's for this. And it just fits within the domain. So that's good. Now let's look at the negative side. I'm just going to draw that quadrant one more time. Now tangent is negative in this quadrant and this quadrant. So the fourth quadrant, we will not be looking into it anymore because our domain is only up until pi radians or range, right? So, but we don't need that anymore. So we only look into the second quadrant. Okay, so I'm going to draw like this. So the angle that we are looking for is from here to here. And the angle or the basic angle that we have is 0.902. So we call this as a basic angle because it's the angle that is always subtended between the line and the x-axis. So the line and the x-axis, right? And this angle from the beginning of the first quadrant up until the line, that's the angle that we always want to calculate. So that's the final answer basically. So in order to find this, we take pi, 180 degrees, minus 0.902. So this will give me the final answer, which is 2.224. Yeah. So give the answer in 3 significant figures. All right. So two answers, 0.902 and 2.24. Let's move on. Question number 2. So this is a question that again uses identity. So we are basically trying to prove the identity. Okay, it's that whatever that is on the left hand side is equivalent to the right hand side. So whenever we do proving identities, we always look to simplify a complex term into a simpler one. So in this case, it's quite easy because we see that on the left hand side, it's a lot more complicated. So I'm going to break this down and try to change this into this. So let's start. So first things first is that I'm looking at this and I see a cotangent. This cotangent is very different from the sine and cos that we have. So we want to try and change this first. So I'm going to change that straight away. So I will get a cos A over sine A for cotangent. Why? Because cotangent is equivalent to 1 over tangent, right? And tangent is actually equivalent to sine over cos. So if I were to revert this with a reciprocal, I'm going to get cos over sine. So that's how I get cotangent A equals to cos over sine. Alright, for some of you this might be easy, but for some of you I'll just explain a bit more in details so that everyone can actually follow. Okay, so just copy back this. Right, so I'm just going to erase this for now. Leave that space. Alright, so this is equivalent to 1 plus cos A. So what I'm trying to do is that I'm going to do a cross multiplication. Okay, cos A plus sine square A, right? So the reason why I need to do cross multiplication is because on the right hand side I don't see a fraction. So which means I need to be able to try and eliminate a fraction, especially because I have two terms here and I have only a single term here. Right. So let's try. Now notice that on the bottom side, I'm not multiplying in as well. So just leave it first. Now I'm going to simplify the top, but the bottom, I'm just going to leave it like that. Okay, so let's continue. So when I expand this and simplify, I'm going to get cos of A plus cos square A plus sine square A. And again, I'm just going to leave the bottom just like that. Okay. And what's the next step? If you notice, at the very top, you actually have an identity. So this identity says, you should remember all of this. So if you have something like this, this must be equivalent to 1. So I'm just going to substitute the entire thing here to become 1. So in the end, I'm going to get 1 plus cos A at the top, sine A, 1 plus cos A at the bottom. Notice this. So the top and the bottom is equivalent, and it's actually something that we can cross or divide. So this will disappear if you simplify it, and you will end up with 1 over sine of A. So of course, the reciprocal trigonometry for 1 over sine A is equivalent to cosecant of A. And you basically have shown it. Alright, hope that makes some sense to you. Okay, we'll go into the next question. I'm gonna erase some of this to give me a bit more white space. Okay, pardon me. Alright, so let's start. So this question is quite simple if you actually know your basics well. The diagram shows a sketch of a curve which is y equals to a sine bx plus c for 0 degrees to 180 degrees. So you are supposed to find a, b, and c, the values that are supposed to be for a, b, and c. Okay, so how do we do that? So the first thing is that we need to be able to identify what these values actually mean. Now, in usual cases, in all cases, y equals to a sine bx actually represents a general formula for trigonometry or trigonometric function. So in our case, a will always stand for amplitude. Alright, so this b represents frequency. Or to put it simply, it's number of cycles. Okay, number of cycles. Whereas c is a vertical translation. Alright, so vertical translation. So vertical translation basically means whether the graph actually moves up or moves down. Okay, positive moves up, negative moves down. Alright, so we are almost there. So let's try and figure it out. So the amplitude, let's look at amplitude. So amplitude is always the maximum value or the minimum value that we actually can find that starts from the initial stage of the graph. Okay, so here, so this is basically your amplitude. So this can also be your amplitude. So it's either you take the minimum or you take the maximum. So it's easier if we focus on the maximum, right? So because we are looking at positive values. So in order to find this, so A or amplitude is actually equivalent to 10 minus, this is 7. So we end up getting 3. So that's your answer. So A is equals to 3. Right. Now, you might be wondering, why did I start from here? So a general sine graph normally starts like this. And we call this x-axis as a principal axis. Okay? But in our case, the principal axis seemed to have moved up. So, but we identify it by looking at where does it start. So the start of the graph must always be this part. Okay? So that's why I started here. Alright, anyway, the next one is frequency. So this frequency usually stands for number of cycles in a period. Okay, so a general period of a sine graph is 2 pi, but we only have it until pi or 180 degrees. Okay, so we have to be careful with that. Now let's count. How many cycles do we have first? 1, 2, 3, and 4. Okay, we have 4, but this is only for 180 degrees. So if I were to include another 180, what you will get? So you'll get 8 cycles. So this is what we have to write in our equation, because the equation, the general equation, always stands for the regular standard 2 pi cycle. All right, so B, okay, I'm just going to put it here. So B must be equivalent to, must be equals to 8. Okay. So the last one, C. So C is the vertical translation that I was talking about earlier. So how much has it actually moved up? Right. So this, for this to understand, for you to understand this, we need to think about mathematical methods to calculate C. So what we do, we take the maximum value, we minus the amplitude. Alright, so in this case, the max value is 10. You minus the amplitude, you are going to get 3, so that should be 7. So your vertical translation here is 7. So C equals to 7. Of course, the A equals to 3. Okay, so on the graph, let's look at why is this a 7, right? So what did I do? I took the 10 and I minused the amplitude from here to here. So this gives me, let's say this was the basic graph, right? So I moved up 7 times. So because I moved up 7 times, that's the reason why I'm going to reach a 10. So let's look at the basic graph. So in the basic graph, if my amplitude was 3, okay, And if I move up 7 times or 7 points upwards, I'm gonna get my maximum as 10. Okay, so that's why that's 7, and that's the reason why we took the maximum minus the amplitude. Right. So after you do this a couple of times, you will be able to understand the patterns behind the graphs. So cos graph will be quite similar with the sine graph. The only difference is we have to be a bit more careful when we see tangent graphs. Okay, right now we don't have to worry about that. Okay, so let's go to the next part of the question. Okay, let me scroll down a little bit. Okay, given that fx equals to 5 cos 3x plus 1. For all x, state the period of f. Okay, so this is something that I didn't show earlier. So the way that we can actually calculate the period of a function, if there are values given, and this is not a general formula, is this. So period is equivalent to 2 pi. Okay, this is the standard 2 pi period, divide by the number of cycles. So you will get a new period that is specific for this particular function. So in this case, our period for each cycle is 2 pi over 3. So that's your answer. Okay. So what about this? The amplitude. So if I want to find the amplitude, what I need to do is I just need to look at the first number here. So the answer is quite simple. It's just 5. By the way, you may want to answer this in degrees as well. Okay, depending on the question. So in this case, you're supposed to, I mean, it's given in degrees, so would be a better idea if you just took 360 divided by 3. So that would be, let me check, 120 degrees. Okay. And we are at the final question, which is question number 4. Is this the final one? Oh, yeah, it is the final one. Okay, so solve the equation. Now, one of the things that I really dislike about trigonometry is that when it comes to solving equations, it can become a bit tedious. But again, you're prone to make careless mistakes in trigonometry solving the equation, but with practice, you should be able to do well. Okay, a couple of things that we need to identify is I always look at what is given here, what's the range that is given here. So my x should be between 0 degrees to 360 degrees. Okay, so then what do? So I have 2 terms of trigonometry here. I can't solve it when I have 2 terms. So we have to find creative ways to get rid of one of them. Okay, or change them into a different term as long as there is one trigonometric term. So in this case, let's make some changes. So I'm gonna keep my sin x on the left hand side, but move my cos to the right. So there's a reason why I'm doing this. The reason is because now you will see if I were to bring my cos over, okay, and my 3 over here, so all my constant values are on the right hand side, whereas all the functions are on the left hand side. Now sine over cos, we have identified previously as part of the basic identities that this should be a tangent. Okay, so this is tangent x equals to 5 over 3. So this helps us to solve the question. The reason is because you no longer have 2 different trigonometric functions. You only have one. So we go back to how we did it previously. So we do the basic angle. So in order to get the basic angle, we do arctangent 5 over 3. Remember, you always have to put the positive value inside to get the basic angle. So my basic angle, okay, is equivalent to, put it inside the calculator. In this case, it's degrees. So make sure your calculator is also in degree mode. And let's find it. So I'm getting 59 degrees. Right. So next is, if you look at this, your tangent is a positive value. 5/3 is a positive value, right? So if I were to draw the tangent diagram for the quadrants, I'm going to get one angle here, which is 59 degrees. This is the basic angle, but it also serves as the answer because it fits within our range. Now, tangent is also positive in which quadrant? So, all science teacher crazy, okay. See, sometimes even I use that quite a lot. Okay, so this is the basic angle, 59 degrees. Okay, sorry about that. It looks like 590. I'm too lazy to make the changes. But this is the angle that we are looking for. So we take the larger angle. So in order to get this angle, what do? We take 180 degrees plus 59 degrees. So this will give me 239 degrees. So for this particular question, we have two answers. One is this quadrant, one is this quadrant. So 239 degrees and 59 degrees are the answers. Okay. So if you want to be a bit more careful, and don't be like me, you might want to answer it like this. X is equals to 59 degrees and 239 degrees. Okay, so just be clear which one's the answer. Right? Especially so because I labeled this as basic angle, right? Okay, now let's move on to one that is a bit more complicated. So this guy. So there are a couple of things here that you have to do. So if you notice, there's a couple of terms here. So we have sine square y, 9 cos y minus 3 equals to 0. And the domain, the y values are from 0 to 360 degrees. Sorry, I keep interchanging the name, either domain or range. It doesn't matter as long as it's a value that is between 0 to 360 degrees. Yeah, it's easier to say that. Okay, now, what do we do? So let's look at this. So I have a square, but here I have a cos, and I have two different terms of trigonometry. What if I used the identity and changed the sine square y? So that's the first thing I'm going to do. You can change it either in terms of cos or sine, but this is the easiest thing to do. So let me change this in terms of cos. Okay. Then plus 9 cos y minus 3 equals to 0. Okay, notice that this is an identity. So sine square y is equivalent to 1 minus cos square y. Okay, so I'm going to expand this and I'm going to get negative 5 cos square y plus 9 cos y plus 2 equals to 0. So change the negative, so become 5 cos y minus 9 cos y minus 2 equals to 0. This is okay, but if you're not comfortable working with negatives, just change it to positive. I prefer to always change it to positive because it gives me an easier perspective of what the final answer could be like. Okay, right. So you can either use your calculator or other methodology to factorize this. Notice that this is actually quite similar to 5x squared minus 9x minus 2 equals to 0. It's a quadratic function, right? So simplify this using a quadratic methodology and you end up, factorize it. So you will end up with cos y minus 2, 5 cos y plus 1 equals to 0. So let me just erase this. Okay. So now notice that you have two answers. Okay. So I'm just going to split this into two parts. So on one side, cos y is equals to 2. On the other side, cos y is equals to negative 1 over 5. Now, common mistake is trying to find answer for this, but you might know that if you try it in your calculator, this will not give you an answer. So this will give you a math error. There is no solution. So the reason being is that the maximum value for a cos function is always 1. Okay, and the minimum value for a cos function is always negative of 1. So if there's any value above those things or less than those, that means there will be no solution. Okay, so you can try trying to put cos inverse of 2 in your calculator, you will get math error. But anyway, let's go back to this. So we have one probable solution. So this is within the range of cos. So the first thing you need to do again is trying to find the basic angle. Okay, so when you find the basic angle, please use the positive value. Alright, do not put the negative inside. So just put the positive value and you end up getting 78.5 degrees. Now you must understand that it's not always that the basic angle will be part of your final answer. Right? I think this question will be one of those questions where the basic angle is not the final answer. So it's a common errors that students usually make. So let me show you what I mean by that. Let me draw the quadrant. Okay, so cos is actually negative here, right? So cos can only be negative where? So all sine, yeah, okay. Here is negative for cos, and here should be negative for cos. This quadrant is positive, this quadrant is positive. All right, so the two angles that we are looking for is this one, all right, and then the other one I'm just going to use a green color, and this guy. Okay, but the basic angle that we have is the one that we calculated earlier, which is in between here. So from here to here, which is 78.5. Okay, and this, just this part is 78.5. Remember that I mentioned it must be subtended to the x-axis, right, and the line of cos. Okay, in this case it's cos. All right, so let's look at this. So for the red one, it's quite easy to find. Okay, so this is 180 degrees minus 78.5. So this would give me, let me calculate, this is about 101.5 degrees. Okay, hope I didn't make that mistake. Right, yep, correct. Okay, and the green one is, you take 180 degrees, that covers the entire line here. So from here to here, plus, okay, 78.5 degrees. So this would give you 258.5 degrees. All right, so notice that again, this is the basic angle. This is not your answer. So to be very specific at the very end, it's best for you to rewrite the answers. Okay, comma, 258.5 degrees. Okay, signify that this is your final, these are your final answers. So this is not your final answer, right? If not, you'll be marked as wrong. Okay, so let's move on to the final one. Solve sine 3 minus z equals to 0.8 for z is in between 0 to pi radians. So it's in radians. So make sure you set your calculator in radians. And let's try to solve this question. So this is also a bit tricky where people tend to make a lot of calculus mistakes. So let's look at the best way to do it. Okay, so step number 1, take out the bracket and we try to find sine inverse or arc tangent, arc sine, okay, of 0.8. So keep this guy here and I'm going to end up with 0.927. So keep this guy on the left. Keep it just like that. So this, we are going to consider this as your basic angle. And again, we're going to make use of the quadrant. Let's do that. Right. So in our case here, sine is a positive value. So we're given a positive value. Therefore, the value should be in this quadrant, all signed, so this quadrant. So we have two quadrants. Again, from here to here, and the second one is from here to here. So let's look at this one first. This one is quite easy because we already have that basic angle. So this is 0.927. In our case, so we look at the two answers separately. 3 minus z, we can now safely equate it to 0.927 and then try to find the answer for this. Answer for z, simplify negative 2.073. Make sure you eliminate the negatives so you get a positive value. Alright, you can change this into a 3 significant figure, but I'm just going to leave it like this. Alright. Then on the other side is this guy. Right, so this guy should be 0.927. Okay, so what do I need to do? So the first thing I need to do is to take 3 minus 7. 3 minus z. Sorry about that. It looks like a 7. Okay, so the entire thing is pi, right? Okay, so in order for me to get from here to here, I need to take pi minus this angle. So I take pi minus 0.927. Alright, then I rearrange and find my z. So this should give me about, bring the 3 over and everything simplify, you should get negative 0.785. Okay, simplify, make it positive 0.785. Again, double check with my the between range that is given to me, right? So radians itself, pi radians is 3.142 something, right? So 2.073 fits there. This 0.785 also fits within the range. Okay, so these two are your answers. Now, just as a bonus, I'll let you I'll identify for you what's the careless mistake that people tend to do. So they tend to calculate this first, okay, find the z, and then use that as a base angle. So that would be wrong, but it commonly happens. Okay, so you don't want to do that. Alright, so that's about it for this particular exercise. So if you found this video helpful for you, please help me to subscribe for the channel, and if you have any comments, just drop your comments, and that's about it. And please, in my previous video I made a mistake, and if you identify any other mistakes in this particular session, please drop a comment as well. So I'll try to make more videos regularly. Thank you.